Our next unit is Laplace Transform. So in this unit we are taking f of t is a function of real variable t, small letter t, and this t is greater than equal to 0. And Laplace transform of the function f of t is denoted and defined by L of f of t is equal to integral 0 to infinity e to the power of minus st f of t into dt. Here this s is the parameter which is real or constant, and we take L is the Laplace transform of f of t. So here we will take this is also equal to capital F of s. On the right hand side we are taking capital F of s. So this capital F of s is known as the Laplace transform of the function small f of t, and this small f of t is itself in a inverse Laplace transform. So we will take this small L of small f of t is equal to this capital F of s. When we take this L to the right side, small f of t is equal to L inverse of capital F of s. Means f of s is the Laplace transform of the function f of t, and f of t itself is the inverse Laplace transform of the function capital F of s. Here we have properties of Laplace transform. Properties of Laplace transform. In the first property, we have theorem 1. This property is known as linearity property. Linearity property. So here the function f of t, we are taking two functions f of t and g of t. If the function f of t and g of t are two functions whose Laplace transform exist, and if we take a and b which are any two constants, then we can write L of a into f of t plus b into g of t. This is equal to, when we separate them, we get a into L of f of t plus b into L of g of t. This property is our linearity property, where we are taking two functions f of t and g of t, and we are taking two constants a and b. When we write L of a into f of t plus b into g of t, this is equal to a into L of f of t plus b into L of g of t. This is the first property. Second property, theorem 2. Here we have this property is known as first shifting property. First shifting property. So in this property we are taking L of f of t is equal to f of s. By the definition of Laplace transform, we have this condition L of f of t is equal to f of s. So in place of this f of t, if we write L of e power of at into f of t, then the right hand side becomes f of s minus a. Means this is our function L of f of t, we are simply writing f of s. When we take e to the power of at f of t, so a is positive, but when we write on the right hand side, it becomes f of s minus a. If we have minus at into f of t, then it becomes f of s plus a. Now, our third theorem, theorem number 3, this is known as change of scale property. Change of scale property. Here, by the definition of Laplace transform, we have L of f of t is equal to capital F of s. So, in place of t, if we write L of f of at, the coefficient of t comes in the denominator and it becomes 1 by a into f of s by a. We will derive this formula in the next video.